Economics Homework Help. Microeconomic Theory Homework Help. To get more info, please visit https://www.economicshomeworkhelper.com. Email info@economicshomeworkhelper.com. Contact us +1 678 648 4277. Question 1. Let x be a random variable with n discrete outcomes x1, xn. The probability of each outcome depends on a privately chosen action by an agent. The agent can either choose L or H. If the agent chooses L, the probability vector for x is PL equals PL1, PLn. If the agent chooses H, the probability vector for x is PH equals PH1, PHn. Assume that the monotone likelihood ratio property, MLRP, holds strictly, that is, PHI/PLI is strictly increasing in I. The agent's preferences can be represented by the separable utility function U, SE equals SCE, where S is the payment by the principal to the agent and E is the agent's unobserved action, E equals L or H. Assume C, H, C, L equals 0. The principal's utility is V, XS equals. Economics Homework Help. XS. Thus, both the agent and the principal are risk neutral. However, the agent has no wealth, which constrains the principal's payment to be non-negative, SI greater than or equal to 0 for every outcome 11. A. Set up the program that implements H at the minimum expected cost to the principal, accounting for the agent's limited liability constraint. B. Show that in the minimum cost contract, SI equals 0 for I equals 1N1 and SN 0. Question 2. Adam is thinking about buying fire insurance for his summer house. The probability that the house is going to catch fire is assessed to be 1 in 10.10. This probability is exogenous and not affected by anything Adam does. If the house catches fire, the damage is going to be either 1,000 or 2,000 with probabilities depending on whether Adam has prepared himself for a fire or not, bought fire extinguisher, etc. Adam's opportunity cost of preparing himself for a fire is C greater than 0. Assume Adam's level of preparation cannot be observed by the insurance company. If Adam is prepared, the probability that the damage from the fire is 2,000 equals 0.5. If Adam isn't prepared, that same probability is 0.7. Adam's utility function takes the form U(m) minus cost of preparing for fire. Here U is A. Economics Homework Help. Strictly concave utility function over money M. Set up a program that identifies the second best insurance plan in which Adam prepares himself for a fire and the insurance company makes 0 profits. B. Solve for the second best solution in part A. In terms of payoffs to Adam in the 3 cases, no fire, fire and damage is 1,000, fire and damage is 2,000, use notation S1, S2, S3 for Adam's payoffs in these 3 cases. You will not be able to solve payoffs in closed form, but you should be able to provide a characterization and interpretation of the second best contract. Suppose now that Adam has a third option. He can prepare for a fire in a manner that would entirely eliminate the chance of incurring the 2,000 damage, at some higher cost C greater than C. Describe qualitatively the optimal insurance contract that implements this new level of preparedness in the most efficient manner. Question 3. In the linear incentive model, assume the cost function of the agent is C, E, S equals 1/2 E plus S, 2 minus S, where E is time put into working for the principal and S is time spent with family and friends. The negative sign in front of S comes from the fact that the agent values time spent with family and friends. The agent's utility function is exponential. Economics Homework Help. With risk aversion coefficient R equals 2. Output from work is X equals E plus theta, where theta is normally distributed with mean 0 and variance 4. Suppose the incentive coefficient alpha equals 0.3. How much time will the agent spend on family and friends? B. Suppose the principal can set S equals 0 by asking the agent to come to the office each day. What is the optimal choice of alpha in that case? C. Suppose the agent's best alternative to working for the principal is spending time with family and friends. What will the principal have to pay the agent as a fixed salary, beta, in Part B? Question 4. This question is about optimal contracting in a principal-agent model with uniform distribution function. Let the production technology be described by X equals E plus theta. The agent chooses effort E privately, the principal cannot observe E. The principal observes X, which therefore can be used as a basis for contracting. Assume theta is distributed uniformly on 0, 1. The agent's utility function takes the form U, M, E, equals U, M, C, E, over money M and effort E. Here U is concave, C is convex, and both are increasing functions. The principal is risk neutral. A. What is the first best contract, i.e. the contract when E can be observed and contracted on? Economics Homework Help. B. Show that the first best outcome can be achieved even when E is not observed by the principal. That is, show that in the special case of a uniform distribution the principal-agent problem does not entail any welfare loss relative to the first best. Question 1. A. The program is the following. The first constraint is the agent's IC constraint, and the second is the limited liability constraint. Solution. B. Let N nu I be the Lagrange multipliers of the two constraints, respectively. Then the first-order conditions can be written as follows. Notice that all multipliers are non-negative and a multiplier is 0 only if its corresponding constraint is not binding. Economics Homework Help. Suppose that equals 0. Then nu I equals 1 for all I, which implies that Si equals 0 for all I, which cannot satisfy the agent's IC constraint. Therefore, 0. The strict MLRP implies that pH of I minus PL, I/pH of I, is strictly increasing in I, which further implies that nu I is strictly decreasing in I. Therefore, nu I 0 and Si equals 0 for I equals 1, 2, n minus 1. Finally, Sn 0 since otherwise the agent's IC constraint cannot be satisfied. Question 2. A. Let P&F be the probability that there is no fire, P2E the probability that damage is 2000 when atom exerts effort, and P2NE the probability that damage is 2000 when atom does not exert effort. Let X1, X2, and X3 be atom's consumption in these three. Economics Homework Help. Cases. Here is the program. Where W is atom's initial wealth. B. If atom's IC constraint is not binding, X2 equals X3 at optimality and the IC constraint is violated. If the company's IR constraint is not binding, then all X's are in a fight. Therefore, both constraints are binding. Let lambda 0 and 0 be Lagrange multipliers of the two constraints. Then the FOCs are. Economics Homework Help. Therefore, U, X2, U, X1, U, X3. Since U is strictly concave, U is strictly decreasing, so X3, X1, X2. The same ordering is true for the S's. Here is the intuition. We want to encourage atom to exert the effort, so we need X2, X3 to give him incentive. On the other hand, we want to insure him against the risk of fire, so we want to choose X1 in between. C. Since the damage of 2000 does not occur in reality, we can make atom's payoff as low as possible in that case. Then we set S1 equals S2 and check if the IC constraint is satisfied. If for some reason, such as limited liability, the IC constraint is not satisfied, then S1, S2. Question 3. A. The agent maximizes. Economics Homework Help. For alpha equals 0.3, E equals 0